So, welcome to the video lecture series of convective heat transfer. Basically, we know that convective heat transfer means the heat transfer of liquid surfaces. But in this chapter, we will discuss about the how this convective heat transfer is occupied in a laminar over flat plate. And before going to this topic, we will explain about what are the factors to be occupied in the flat plate during the heat transfer of convection phenomena. For example, if we consider any type of solid plate or any type of circular pipe which contains, which overthrow about the transfer of heat phenomena through the liquid medium. So, in this forced convection laminar over plate, this factor is basically depend upon the values of the turbulent and laminar flow parameters with respect to the Reynolds number. And basically, we know about the Reynolds number value is indicated about the ratio of uh, flow surfaces into the viscous to inertia forces. So in this parameter, here it is in the plant plate. The thermal analysis, it is an important better role in the post convection parameters. And basically, there are two types of convection is indicated in the flat plate or any circular or cylindrical phases, which is known as the forced convection, and another one is the natural convection. So for example, the free convection, it is the indicator is the said to be is the natural convection. Here there is any type of no forces or any type of no external forces will occupied in this area. That is called as the natural convection. And this forced convection, it is opponently by the natural convection due to here the air or any blower fan or any type of any external type of sources will be using for this purpose for this type of forced convection. And lot of applications will be involved in the forced and free convection is used in many type of engineering solutions like aerospace, automotive, and civil engineering structure and mechanical and thermal automation structure. So now we have to introduce about types of key parameters and types of numbers and types of parameters and some type of governing equations. So basically, we know that dimensions are L and V and T, like length and velocity and temperatures. These key parameters are will playing a vital role in the dimensions number concept, like as Prandtl number, Nusselt number, and Gauss number, and also this we already said that about the Reynolds number. And these fluid parameters are also which indicated about the density, viscosity, thermal conductivity, and also that specific heat capacities also. And now these key parameters and dimensions numbers and the fluid properties are will be occupied in the governing equation like is in a continuity, momentum, and energy equations. And it is already we said that about laminar flow means it is in a continuous path. So there is no any type of deviation or any type of zigzag flow will not occupied in that fluid motion. But in the opponent of the turbulent flow, it will be the surely it will be continuous or affect about the zigzag flow. And consider about the plot boundary layers, boundary layer concept. So this is there is some intention or some reduction will be during the particular direction or particular object or beyond this object surface. It will be types of it's a three type. It is in a thermal boundary layer and hydrodynamic boundary layer, and another basic one is in a normal type of boundary layer concept. And this calculation analysis of the flat plate, the boundary layer thickness which indicated by the symbol of a delta, and the coefficient which is indicated by the C insufficient of Fx. And analysis, we respect with whom the equation, right, Prandtl equation and Nusselt equation, and the equation is with respect to the delta and del T concept. And basically, we know about the local heat transfer coefficient is directly contacting surfaces between the medium and inner and outer layer surfaces. It should be definitely effect of the heat transfer phenomena with respect to the particular area in the plot dimension directions. And finally, we are focusing about the flat plate heat transfer application is in cooling systems and heat exchangers like thermal boilers and thermal reservoirs, and the concept of aerodynamics like in any object will be moving about the air, and the collection of solar heaters. And these are the final summary of these flat plate conduction is including dimensionless numbers, dimensions and equations, and the flow parameters also. Thank you.